So for this project, you need the Arduino Uno based on the Atmega 328 chip, the TMP102 temperature sensor, 2 LEDs, 2 1K resistors to go with those LEDs, a Piezo buzzer, the USB connector for the Arduino, and MATLAB. Looking at the Arduino code, we start by including the wire.h library so we can communicate with the I2C. We initialize the integer address of the address 0 pin on the TMP102. We initialize our buzzer, green and red LED. We initialize the LED brightness values, 255 for max, 0 for off. We initialize our peak temperature that we want our alarm to sound to. We initialize a random value to mode, which is for serial read. And lastly, we initialize a variable Celsius to a float for our get temperature function. In the setup, we set up serial at a baud rate of 9600. We begin our wire. We also set our buzzer, green and red LED to output. Here we have this simple while loop to communicate between Arduino and MATLAB. Arduino sends an A, MATLAB receives it, sends an A back to Arduino. Message box will appear on MATLAB, and Arduino will send the peak temperature that we set to MATLAB. In the loop, we check if anything's on the serial. Mode will read anything on the serial. If mode happens to be T, it'll run the get temperature function and print the resulting Celsius temperature. If Celsius is less than the peak temperature that we set, the green LED will be on. If the Celsius is greater than the temperature that we set, then the red LED will be on and the beeper function will be called. In the beeper function, it's simply a tone on pin 9 at 15 kHz with a delay set by the user, in this case 20 milliseconds, followed by a no tone on pin 9, or else the buzzer will beep forever. In the get temperature function, we do the wire.request request from with the address of the address pin, and we get a 2-bit reading. In our 2 bits, we set to MSB and LSB. Then we have integer temp, which shifts the most significant bit to the left 8 and bitwise ORs it with the least significant bit, and then shifts that entire sum to the right by 4. We then multiply that sum by 0.0625, which gets us the Celsius conversion. Now in MATLAB, we start with our serial setup function. Here it waits to receive an A from Arduino. It will then send an A back to Arduino. When that connection has been made, a message box will appear saying serial communication has been set up. Next, we have our max temp function, which just simply reads what the max temperature is when Arduino sends it. Next, we have our temp graph function, which creates the axes and the surface plot for our temperature readings, and it color codes it based on temperature. Here's the while loop that constantly reads the temperature readings from the Arduino. This is the function that we call to make the reading. And then lastly, our close serial function. And to display it all, we have a GUI. We hit the start button. The message box appears, serial communication has been set up. The graph appears. Temperature data is indicated below with our peak temperature that we set and the current temperature. And as we increase the temperature past the peak, the alarm will sound. And when we are done, we simply close the serial. Here you can see an overhead view of the circuit design. Here you have your TMP102 temperature sensor, your 1K resistor for your green LED, your 1K resistor for your red LED, and the buzzer. Thank you for watching.